Thank you.
We need to move on to our next presenter here.
Sure. All right, thanks,
James Simmons from Oak Ridge National Labs. James has been an active Linux kernel developer since 1999. This development has been from small embedded systems to large supercomputers. So,
can you see it?
We see your screen, James.
Yes. All right. All right, so I wanted to talk about the Linux Lustre client state. So this is a status update as of this month, and where we're at and where have we come from. So this is a very, very long project. It's been going on for 6 years. Originally, EMC pushed it to the staging tree. Lustre wasn't really ready for that kind of thing. So the staging tree had lots of requirements for it to be acceptable to be supported. So after, also another thing is, as Peter Jones can attest, and I don't think people understand and realize, is that supporting Lustre on the platform is a very expensive proposition. There's a lot of development efforts, testing efforts to go in about these kind of projects. So that's quite a lot of work. And EMC found this out. So after about a year, they just stopped contributing to the project. So the project was kind of just left in limbo for a long time. Over time, Oleg ended up maintaining it for 2 years. And he got involved and he kept it alive after EMC dropped the ball. And then as that process went on, though, it didn't seem like it was going anywhere much. So I became involved with this project and have been doing it for over 3 years now. And I have taken over the reins of managing this project. During that time, the Lustre client was dropped out of staging, and due to the lack of contribution at that time. And so it was moved to a private repo to continue that work. During that time, during the time it was getting ready to drop out of staging, actually SUSE became involved in the project. Neil Brown has been a very active contributor, and SUSE has contributed full support for the Linux native Lustre client. So over that time, also the client was kind of old and broken. So by the time of last year, we got it up to a 2.10 release. We were actually starting to sync in with the current. We were a few versions behind. So we ended up doing a huge catch-up game. So over the last year, we went from doing 2.10 to actually being in sync with master, and we still are in sync with master. So this is actually a really good thing. So we've also reached the point where the workflow is from the Linux client to the OpenSFS branch. So now all the improvements and changes that have been done, that were done in while it was in staging and from Neil and myself in the upstream client, is actually backflowing. So some of the benefits to the OpenSFS branch from this is support for newer kernels. So rapid support for newer distros like Ubuntu 20 is already done. And for example, right now, OpenSFS is up to we just got the client support, Ubuntu 20, the HWE release. So for people who don't know what that is, Ubuntu does a long-term release with an earlier Linux LTS kernels. So Linux kernel also does LTS. That was like a 5.4 kernel. The HWE version supports a 5.8 kernel. So we've actually just finished off that support, and actually technically the OpenSFS branch supports a 5.10 kernel. Another benefit of this is that we support the latest MoFed stacks, since the MoFed stack does this very similar thing to like the Lustre Linux client does. It follows the latest Linux tree and backports it. Other good benefits that we saw, like during 2.14 and 2.15, is performance gains. So there was a couple tickets, some changes were done to support, like LU object cache. We kind of broke up the global lock. We went to our hash table implementations. What's our lock list? So the hash tables actually performed a lot better. We saw in some cases stat improvements double, moving to this kind of to those hash tables. So at this time, we are at a Linux 5.8 version for complete support, and we are moving to a 5.12 kernel support for the Linux client, and this is true also with OpenSFS. So this is actually a good community effort. So it's mainly driven by Neil Brown from SUSE and myself from ORNL. Others have participated, seem to have an interest. Amazon seems to have an interest in this work. Arilan Durmong has done code reviews, and Arshad has done a lot of great work. I'm thankful that these people participate and review all the work that is being done. So now that we are in sync, the question is, how healthy is it? So I do active testing, and so does Neil. We do the same testing as any other community project. So there are several projects out there like Ubuntu and ARM that are part of the WAM Cloud tree, and they're actually being tested. So those don't get the full range of testing as like a RHEL distribution does. So it's usually sanity test and sanity LNet test. It's a lighter form of testing, though at tags it is actually more heavily tested. So for myself, internally, I've been manually doing test suites based on the latest master branch against the Linux client. I do a much more comprehensive suite now. I test more than just sanity testing. The nice thing is there are subtle differences between the Linux client and the OpenSFS branch. So the tests have all been updated over the last year to support it. So the test failures you'll see are pretty much actually the reality of the test failures, because there are some differences that the Linux client, native client, doesn't do that the OpenSFS branch does, such as the job ID, some of the types of job IDs that are done. So to make this testing possible, we're trying to get it to the position where we can actually run the Lustre utilities against the Linux client, and we have a ticket open for this. So there's been work to be done so that when you build Lustre, you do your checkout from WAM Cloud, you can actually just build the utilities, and it'll build against the native client. And so it mostly works. There's a couple changes that need to be updated. So wire testing needs to be changed, and also two of the utilities, there's small changes left. Well, they're not small, but there are some changes left that we hope to get done for 2.15. So this means that in the future, you'll be able to just do a configure, disable server, disable modules, and build your Lustre utilities and be able to test with this. With this being done, it'll be very easy to be able to set up a Malu type of system where we can do auto testing of the Linux client. And that's actually the ultimate goal, is to reach that point where we can do the same level of testing. And ORNL has been discussing with WAM Cloud about automated testing for a couple reasons. So we're actually looking to doing this kind of work. So currently WAM Cloud does all of the testing, and that's a heavy burden. So we've been discussing how that workload could be distributed. So, and what we found in our testing is that basically the same bugs show up in both trees. Once in a while, we do see a newer kernel, a bug due to a newer kernel, like for HSM, we saw that in the Linux native client first, and then we reported it and fixed it. And then lo and behold, a couple of weeks later, Ubuntu 20 support was added, and that same bug was there and it was fixed. So there's only one large source of failure, and that's the FID lookup cache issue. So that is broken in the Linux client, and there's 2 tickets that are primary for that. So there's a lot of issues with how FIDs are done and how they're looked up that cause failures in the upstream kernels, some of the stuff that's being done in the dcache is considered invalid in newer kernels. Right now, it just gives you warnings, but in the future, it could actually report that your dcache is corrupt. So this is something that needs to be addressed, and I have not addressed it yet. I have some proto patches to fix that. And as I said, I've been expanding that, so it's been a lot of bugs squashing mode to fix all this stuff. There's only a few bugs. It's outside of the FID lookup. It's pretty minimum. So the good news is that with all these things going on, that actually we're almost getting near the end of this, the Linux native client project. So we have a ticket. If you look at that URL, you can actually see what some of these changes are. So there are a couple of big items left that needs to be done. The Jira ticket. So you can actually see that when we do Jira tickets, we actually do label them as upstream when there are issues. We also have a general ticket that tracks all this work being done. The biggest barrier for submission upstream is actually IP version 6 support. So what we actually, Neil actually looked to push what we had already to the Linux client tree. So we would have actually been in the native Linux kernel tree, but Dave Miller said, well, we really want IP version 6 support for any kind of networking layers, and that's lacking in LNet. So that work is actually being done, and it's actually being slated to land for 2.15. And a lot of the work is actually landed even during 2.14. So it's actually been it's pretty active project right now. We're trying to work on the marshaling of the wire protocols and with LNet NIDs and how they're represented. Another thing is IB support. So Chris Helwig does not like our K2 IBLD driver. We do a lot of things manually, and there's a new generic RDMA framework that was developed, and it's actually supported in all the kernels. It's even in RHEL 7 because it was needed to support OPA when they backported that to the RHEL 7 kernels. So actually, we could implement this API in our drivers, and it would actually reduce the size of the driver a lot. So a lot of the FMR pool handling and the fast registration registers that are used by IB are hidden behind this protocol. So that's a nice cleanup to be done. And of course, as testing expands, we've been actually squashing as many bugs as we see. Sometimes unique bugs show up in newer kernels. Sometimes the issue is that sometimes patches are not 100% ported completely correctly. You can miss things because of the way the trees are different. There are certain macros that are in the OpenSFS tree that are in the Linux client. So things can not apply, or they apply slightly differently. So what are these big ticket items left? Probably the biggest one is probably the proc handling. So in newer kernels, they've been removing everything from proc, the proc tree. And that's been moved to the SysFS tree as well as debugfs. So if you look at our native Linux client, we don't use the proc tree. This does affect tools like for job ID and things like that. The reason is because debugfs it is only root only. So it only allows root access. So there's a lot of information that you can't access. Though I did see in the latest kernels, you can now allow non-root access to debugfs. So they have changed that, but that is a kernel option. And the reason for this is historically, some of the stuff that ended up in debugfs introduced security holes. So we also have to enforce proper SysFS file naming. Historically, there have been issues with our tunable naming schemes. Sometimes it was related to moving to SysFS, sometimes it wasn't. Sometimes naming was done incorrectly. So we need to ensure that that does not break as we move along or things don't get dropped. And probably the other largest thing is the introduction of Netlink to Lustre. So Netlink there's a Netlink protocol that's being added. So one of the things is DebugFS is used for a lot of stat collection. So, and currently with stats, you have to open hundreds of stat files to collect stats on a large file system. This is not very performant. So actually, you can use Netlink to multiplex these streams and collect stats. So it allows actually a much better scaling opportunity here. You can also do a lot of things. Netlink offers a lot of advantage that you can not worry about changing the format of your data. So there's not interoperability issues with older Lustre versions. So that's actually a nice feature. So if you have newer tools with older tools, you don't have this breakage. The Netlink is being implemented that is a YAML to Netlink interface. So everything is expressed in proper YAML. And this is being used actually for more than just DebugFS. We're using it for actually LNet self-tests. So one of the things that LNet self-tests has this interactive tool, but we're going to actually allow the ability to pass a YAML file to do your LNet self-testing. And then it'll do it through this Netlink interface and allow you to set it up and run elaborate tests. So that's actually a nice project. There's some of that work has already been pushed, and that overlaps with the LNet self-test work. So LNet self-test itself does a lot of questionable things with its ioctl interface, with pushing pointers from user space to kernel space and things like that. So it also does not work with newer kernels. Unlike RHEL 8, it fails the smoke test. So currently it only runs really on RHEL 7 in the test suite. So I'm going through that and trying to resolve those issues as well to make LNet self-test reliable on all the platforms. So that covers that for proc and LNet. The other thing is the hash table. So OpenSFS has its own hash table. That hash table is actually quite expensive. So we've been looking to move to our hash tables, which is lockless, uses RCU locking, which is very, very lightweight and highly performant. And also X-arrays. So X-arrays are actually a nice new feature that would develop for page caches. It's a nice, there are some places where we have sequential data being stored in hash tables, which is not the most optimal setup, but X-arrays are more of a sequential data. Examples of that is like our quotas, and there's some HSM stuff on the MDT that does that's sequential, but it's stuffed into an R hash table. Another problem is the way we handle our SysFS file namings. So if you look at the SysFS files, they're like the name of the file system dash, and then the abstraction layer like LMV or something, and then some kind of number. So that number is actually a kernel space pointer address, and that's actually considered a security violation in the Linux kernel. So that's the ASLR. So one of the ideas is to move to using UUIDs for that. So to make that compliant. Also, that gives us the ability to do mounting with UUIDs. So one of the things you can do with file systems is use UUIDs to actually mount instead of path name. And of course, the last thing is the FID lookup cache. So that's being addressed. There's lots of problems with that. Like file sets don't work with the FID cache the way it works. So there's like a FID to path kind of command, and that's basically the overlap with that. But if you do like a submount with file sets, it can't read that. There's a special place where you read it in the directory tree for these FIDs to map it, but that doesn't work with file sets. And as I addressed it before, what those issues were. All right, so those are what the issues that lie ahead. Most of those issues, though, for servers, is most of the client stuff has been done in the OpenSFS branch, so there's not actually a huge hurdle left. So everything that we do ends up in the servers get updated as well. So this is a lower barrier down the road. As we look to merge upstream, once we do merge upstream, the good news is that the Lustre client will start showing up in distros. This will be an interesting thing because this will mean that distributions will start to have to do the load to managing these issues. So SUSE, of course, because they're supporters of this project, they'll provide good support. And as you know, WAM Cloud is focused on CentOS. So when the client starts showing up in CentOS or RHEL or any derivative like that, WAM Cloud will be focused. Ubuntu is the unknown. It's the closest to the upstream client, but we'll have to figure out who with the Ubuntu community will be able to participate in this kind of project, especially as Ubuntu is becoming a very popular distribution to use Lustre with. So that's the good news. The LTS support will be for Lustre will be different then, because basically the Linux kernel will determine what the LTS will be, because they release LTS kernels that have 6-year support. Usually distributions focus on that version of the kernel for their distribution. So we will have to do a race if whatever Lustre version wants to be LTS, that will be the one that will be released with Linus's tree that's marked as LTS. Of course, as like I discussed earlier, bug triaging and external testing will probably start to move outside of WAM Cloud. WAM Cloud will no longer endure the burden of all that work. This is leads also to the second goal, and the main reason, a good reason for this is new developers to enter the community. So as Lustre becomes part of the general Linux kernel community, we should be seeing new developers from external outside the community start to participate in this project. When we were in the staging tree, we actually saw there were actually some bugs, real legitimate bugs actually fixed. And those were eventually backported to the OpenSFS branch. And this is the kind of participation for the survival of Lustre in the long run that needs to be done. What is the long-term goal? And that is to move the entire OpenSFS tree to the Linux kernel. So eventually all the server stuff will not too long after the client, the focus will be moving to move the server upstream. And so what are the barriers for that? ext4 support for LDiskFS. So LDiskFS is an extension of ext4. So all the work that ext4 is very lacking, so we just can't use the defaults. The good news is the barrier, the change between ext4 and LDiskFS is shrinking all the time. So there's only a couple things that are in LDiskFS that really need to be ported there. Like one of the things is parallel directory lookup, and I have a link to a patch of a suggestion to implement that in the VFS layer. So we're going to probably end up implementing that at some time in the Linux kernel and push that forward, and then LDiskFS will be adapted to use this new feature. And as I was saying, all the changes from the upstream are applied to the entire OpenSFS tree, so it won't be a huge job to do this work. So the barrier to moving the client is a much larger barrier, but once that is complete, the server stuff is much smaller. It'll be a much quicker event. So that's the status of it. So the question is community involvement. So how can you become involved for this, and what do we need, especially since probably by the time 2.15 is released, this is with IP version 6 being done and all merged in, we're looking at probably the 2.15 timeframe when that's released, we're looking to see that be merged into the Linux kernel. So that is probably toward the end of this year. We're going to make a push for that. Now, there's no guarantee that it'll be merged right away. There could be feedback that we didn't expect, but we've had discussions before with like Alvaro about like some of the things that are, so what are the barriers, and we've been trying to address them. And Neil has been in discussions about those kind of things as well. So we also need greater scope of testing for Lustre for the client to see how it is. You know, testing always exposes unique bugs. It'd be nice to see a site try this. In the past, there have been people when we were in staging, there were sites that actually ran the Linux client. Bless their heart, but they did. And at that time, it was not as in good shape as it is today. But it would be nice, but if sites do that, it would be nice to know if they ran into any issues and we could triage them. You can open tickets at Jira. I left a link to the trees to grab the trees to test it. There's Neil's tree. I have also my own private repo. Mine is more closer to the OpenSFS. Neil likes to put more prototyping work for testing before it's submitted to the OpenSFS branch. There, I left a link to how to do testing. And of course, please open Jira tickets and add the OpenSFS. Add the upstream labels so I can see it. It'll be assigned to me or Neil. And of course, if you have questions, Lustre Devel is the perfect place to ask about this stuff. It's a pretty lightweight list, so don't be like thinking, oh, you're gonna see lots of stuff. Sometimes there's 50 some patches that get posted for the Linux client work for review, but it's not a heavily active. Note this list is for technical discussions, so don't feel bad if it's over your head. It might be a good way to learn technical details internal that you didn't know before. And of course, if your company would love to get involved, the Lustre working group, we're always actively discussing where we're at for this project. So feel free to become active part of the Lustre working group. There's other perks, such as determining what the next LTS is, those discussions that go on there. And of course, this is always discussed at various Lustre conferences like LAD and LUG at the US or China. So this will always be brought up, and you're free to ask anything during these conferences. So what are the conclusions about this project? Mostly works. It's actually in sync with the latest stuff. We are actually getting into the final rounds for merger to Linus's tree. And of course, don't be afraid to be involved in this project. You know, right now it is an actively supported project, so we will respond to issues and stuff. You can ask questions on the developing list, the LWG calls, or report on Jira. Or you can contact me directly. There's my kernel development email address. And I would like to thank the U.S. Department of Energy for doing this, and ORNL for supporting this work. This is quite a long-term project, and they've been very patient with it. And I'm very thankful that they allowed me to do this work. And that's it.
Thank you, James. Having gone through chat here, and it just disappeared on me. There we go. Through chat, and all of the questions have actually been answered that have been asked in line. The most recent one was asking from, this was from Megan. Once the Lustre file system client is in the Linux kernel, will updates of Lustre independent of the kernel become impossible?
That is actually one of the side projects. So besides supporting, I should have brought that up. We are making it so it's gonna be an MOFED kind of model. So I don't know if, you know, MoFed has their own external stack. So you will be able to install and override like the Linux client if it's enabled support. So that's actually being worked. In fact, there are some patches I've already pushed that allows you to build OpenSFS tree, the kernel modules with a native Linux client. That's some of the work being done. So yes, you'll be able to do that. It's going to be very much like how you install MoFed, and MoFed overrides your default IB stack. You'll be able to do that.
All right. Are there any other questions from chat? I've not seen any. All right. Well, thank you very much, James. And there might be a couple more. So if you could stay on and just monitor chat
Oh, yeah,
for a couple
sure.
minutes, I appreciate it.